For a long time now, we've kind of treated prompt engineering like some kind of creative art. But let's be real, in modern software development, that's just not going to cut it anymore. We have to start reframing it as what it actually is, a serious, rigorous engineering discipline. It's absolutely essential for any professional who's collaborating with an AI. So in this explainer, we're going to walk through what a complete professional workflow for this looks like. We'll kick things off by redefining our quality process. Then we'll introduce a formal spec for writing prompts. After that, we'll dive into how to architect complex logic, and we'll finish up with the verification steps you just can't skip. By the end, you'll see exactly how to make that shift from being a casual user to a true AI architect.
All right, the first big idea we need to wrap our heads around is this. Prompt engineering is the new code review. The crucial difference, though, is that unlike a traditional review that happens at the end of the line, this is your most important quality gate at the very beginning of any human-AI collaboration.
You know, this really is a fundamental shift in mindset. Think about it. Traditional code review is totally reactive. We write the code, then we hunt for bugs and fix them. Prompt engineering, on the other hand, is proactive. It's all about designing a super precise specification before a single line of code ever gets generated. This way, you prevent whole categories of errors from even happening in the first place.
Now, to get from just guessing to actually specifying, we need a formal framework. That's exactly where CIRA comes into the picture. And I want to be clear, this isn't just a random collection of tips, it's a full-on engineering specification. It's designed to make sure you get predictable, high-quality results from any AI model you work with. CIRA is an acronym for the 4 pillars that really make up any professional-grade prompt: context, instruction, requirements, and adopting a persona. So let's break down what each of these really means for an engineer on a day-to-day basis. First up, context. This is where you ground the AI in your project's specific reality. You have to give it the essential background information. You know, are we in a React project? Are we using Vitest for our tests? What does the existing file structure look like? If you skip this, the AI is basically just taking a shot in the dark. Providing solid context narrows its focus and makes its output way more relevant.
Next up is instruction. This is the heart of your request, the main action. And let me tell you, ambiguity is your absolute worst enemy here. Don't just say something vague like fix this. Be explicit. Say, refactor this use effect logic into a custom hook and name it use user data. A precise instruction like that leaves zero room for the model to guess what you want. Requirements are your guardrails. This is where you enforce your project's standards and all the technical constraints. You can get really specific here, like do not add any external libraries, or make sure all functions include JS.comments, or all types have to be written in TypeScript. These rules are the non-negotiables that stop the AI from accidentally introducing technical debt into your codebase. And finally, we have adopt a persona. This one is a surprisingly powerful technique. When you tell the AI to act as a senior React architect, you're not just asking it for code, you're asking for code that reflects the experience, the patterns, and the best practices of a seasoned expert. It actually influences the entire architectural style of the final output. It's a game changer.
Okay, so CIRA gives us a really robust way to specify what we want to build. But what about guiding the how? When you're dealing with a complex algorithm or some tricky business logic, how do you make sure the AI's reasoning is actually sound before it even starts writing code?
That's an excellent question, and it leads us perfectly to our next tool, an architectural pattern called chain of thought prompting. And yeah, I'm using the word architectural on purpose here. This isn't some clever little trick. It's a necessary method for breaking down complex problems and making sure the logic holds up.
So the chain of thought technique, it's simple to use, but its effect is pretty profound. You basically tell the model to first explain its reasoning step by step, and only after that to write the code. By forcing the AI to show its work, you get to check its logic before it gets turned into a potentially flawed piece of code. And just look at how simple the prompt is. That one sentence transforms the AI from this black box that just spits out code into a transparent collaborator. It shows you its thinking. This is absolutely invaluable for complex tasks, like trying to map out a multi-step authentication flow. So the whole process unfolds in two very clear stages. First, you get the reasoning output. That's a clear, human-readable plan that you can review for any logical mistakes. Then, once you're happy that the logic is solid, the AI moves on to stage 2. It generates the actual code based on that plan you just validated. This separates the what from the how, a cornerstone of any good engineering practice.
Okay, so we've specified our task with CIRA, and we've guided the logic with chain of thought. But we are not done, not even close. We've now arrived at the final, absolutely non-negotiable quality gate, the human code review. This is where the engineer's accountability is everything.
Let me be as clear as I possibly can be on this. You must never trust AI-generated code blindly. The ultimate responsibility for the quality, the security, and the maintainability of any code that gets committed to your repository lies with you, the engineer. Period.
To do this like a pro, you need a systematic checklist. First, functional correctness. Does this thing actually work and solve the problem? Second, security. Scan for common vulnerabilities, SQL injection, or even more likely, hard-coded secrets. Third, context awareness. Does this code actually fit in with your project's existing patterns? Fourth, performance. Is it efficient, or did it just introduce a lazy algorithm or an N+1 query? And finally, maintainability. Is this code clean? Is it readable? And can the next developer actually understand it?
A huge reason that first item on the checklist, functional correctness, is so critical is because of a behavior we call hallucination. This is when the AI confidently just invents functions, or methods, or API endpoints that sound totally plausible, but they just don't exist. Without you rigorously checking, these hallucinations can lead to some really subtle, hard-to-debug errors at runtime.
Okay, let's bring all of this together. By adopting these structured practices, we're really elevating our own role. We stop being just simple consumers of AI suggestions, and we start becoming true designers, architects of AI-driven solutions.
And this really shows the difference, doesn't it? The reactive prompt user asks a vague question and just kind of hopes for the best. The proactive AI architect, they don't hope. They build a precise CIRA specification, they guide complex logic with chain of thought, and they meticulously validate every single line of output with a checklist. They own the process from start to finish.
So, I'll leave you with this question to think about. As you start working on your next feature, and you inevitably collaborate with an AI, just ask yourself, who's in control here? Who is setting the standards and making the big architectural decisions? Is it you, or is it the model? The answer to that question is going to define your effectiveness as an engineer in this new era.